Okay, let's dive into this. We're going to talk about a huge, kind of hidden environmental problem and a surprisingly tiny green solution. This is the story of how our own medicine is making our water sick, and how some of the most ancient organisms on Earth might just be the cure.
So think about it. You take a pill for a headache, or maybe an antibiotic for an infection. You feel better, and that's pretty much the end of the story, right? But have you ever stopped to wonder where the active ingredient, the actual chemical that did all the work, where does it go?
Yeah, it's not the end of the story at all. After our bodies are done with these drugs, they get excreted. And from there, they enter our wastewater systems, kicking off a journey that leads right back into the environment. And this is where the real problem starts.
And the scale of this problem, it is staggering. This number you're looking at, $1.57 trillion, that's the projected size of the global pharmaceutical market. Now, more medicine is great for us, of course, but it also means a massive and growing stream of these powerful chemicals is flowing into our water.
So let's just trace the path of one of these pills. It all starts with us, or animals, taking the medicine. Then the drugs get processed by the body and flushed into our wastewater systems. Now here's the kicker. Our regular water treatment plants, they just were not built to filter out these super complex molecules. So a lot of it just passes right through and gets dumped directly into our rivers, lakes, and oceans.
So they're out there in the water. What's the big deal? Well, these compounds were designed to have really powerful biological effects on us, and they don't just magically switch off when they hit the water. They have some serious environmental side effects.
And the impact is really widespread and frankly pretty alarming. All those antibiotics in the water, they help create drug-resistant superbugs, which is a massive threat to global health. Hormonal drugs, even in teeny tiny amounts, can completely mess with the biology of aquatic life, leading to things like male fish developing female characteristics. We've even seen total ecological disasters, like the vulture population in Asia just plummeting, and it was all traced back to an anti-inflammatory drug given to livestock.
And here's a twist that makes it even scarier. It's not just the original drugs we need to worry about. As these chemicals float around in the water, they start to break down and form new byproducts. And get this, these transformed compounds can actually be more toxic and stick around in the environment for way longer than the medicine you took in the first place. Okay, so that all sounds pretty bleak, I know. But this is where our story takes a really cool turn, and we get to meet our unlikely hero. It's green, it's microscopic, and it just might be the key to fixing this whole mess. Let's talk about algae.
Now, the official scientific term for this is phycoremediation. Phyco is for algae, and remediation just means to fix something. So putting it simply, it's using algae to clean up our pollution. And this isn't just some neat lab experiment. It's a truly sustainable, powerful approach.
I mean, just look at the difference when you put it side by side with our usual methods. Conventional treatments are expensive, they burn a ton of energy, and they create this toxic sludge we have to get rid of. Algae? They do the exact opposite. It's low cost, they literally breathe in CO2, they release oxygen, and the leftover algae can be turned into useful stuff like biofertilizer. It's a total win-win-win.
So how does it actually work? How can this little green speck take on a complex pharmaceutical? Well, it's not magic, it's just some really elegant biology. Let's break down how this microscopic cleanup crew operates.
It's basically a three-step attack plan. First, you've got biosorption. This is where the pollutants just stick to the outside of the algae, almost like Velcro. Then comes bioaccumulation, where the algae actually pulls those pollutants inside itself. And finally, the most important part, biodegradation. The algae uses its own enzymes to chop up those complex drug molecules into much simpler, safer stuff.
But here's what's fascinating. Not all algae are the same. Different species are good at eating different things. For instance, research shows that this species, Cynodesmus obliquus, is an absolute superstar at removing the antibiotic ciprofloxacin. It can get rid of 84% of it. Other types, like Chlorella vulgaris, aren't nearly as effective on that particular drug. So a huge part of the science is about finding the right algae for the right pollution.
So we've got these amazing little specialists, but what if we could make them even better? You know, the future of this isn't just about algae working solo. It's about creating these powerful teams, both biological and technological. First up, pairing algae with bacteria. They have this amazing partnership. The algae do their photosynthesis thing, which creates oxygen,
And that oxygen is exactly what certain helpful bacteria need to thrive. In return, those bacteria help break down the pollutants even faster. It's a perfect symbiotic relationship, a cleanup crew that's way more powerful together.
We can also give them a technological boost by using something called an advanced oxidation process. Basically, zapping the water with UV light or ozone, we can start to crack open those really tough drug molecules. It's like we're pre-cheering the pollution, breaking it down into smaller, bite-sized pieces that are way easier for the algae to gobble up.
And that brings us to the real big picture idea. The best solution isn't just one thing, it's an entire integrated toolkit. Phycoremediation is the star player for sure, but it's backed up by teams of microbes, by advanced tech, and even by other natural systems like constructed wetlands. You're building this multi-layered defense where every single step makes the next one even better.
And the results of this team approach? Well, they speak for themselves. Studies on these kinds of integrated systems show that they can remove anywhere from 40% to a full 100% of these drugs from the water. That is a game changer compared to what we're doing now.
So, where do we go from here? We have this proven, powerful, nature-based technology. The next big steps are all about figuring out how to scale this up and weave it into the water treatment systems we already have.
You know, if there's one really crucial point to take away from all of this, it's this right here. We created a very modern, very complex pollution problem with our advanced chemistry, and it turns out the solution might just come from one of the simplest and oldest forms of life on this planet. It's a pretty powerful reminder that sometimes the most innovative answers have been right here all along.
So I'll just leave you with that question to think about. As we keep facing these incredibly complex environmental challenges, maybe the answer isn't always a more complicated machine, but a deeper understanding of the elegant and powerful systems that nature has already perfected.